Hi, I'm Jimmy Chang, and we're here to talk about the steps to evaluate radicals related to algebra. Now, we're going to talk about a couple of commonly used radicals, the square roots and the cube roots. You could extend this to higher roots if you prefer. Now, let's talk about the square roots here. We're going to look at numbers first, and then we'll look at variables in terms of radicals. So if you have the square root of 4, for example, those are pretty straightforward because you're looking for if there's a perfect square involved. And because 4 is a perfect square, you know the square root of 4 is indeed 2. And you know, of course, square root of 16 is equal to 4. Now, obviously, if there's not perfect squares, you want to simplify and find any factors that are perfect squares. So, for example, if you have square root of 8, you know square root of 8 is 4 times 2. There are rules that allow you to break it down. Square root of 4 times square root of 2, and that'll give you 2 root of 2. Now, if you have variables, however, it's a little bit different, but it's actually in some ways easier than regular numbers. Let's just say if you want to simplify the square root of x to the 7th. Now, even though the square root, the 2, is not really written because it's implied, you can put the 2 here to kind of show you how to simplify. It's actually a long division problem, a very easy division problem to figure out what the square root of x to the 7th is. Now, if you have, what you do is you take the 2 on the outside and you divide into the exponent 7. As you know, 2 goes into 7 3 times, remainder 1. Now, the fascinating part about this is the 3 gives you the exponent for x that goes outside the radical, and the remainder is the exponent of x that stays in the radical. I will just put x to the first as demonstration, even though it's not normally written. So believe it or not, the square root of x to the 7th is equal to x cubed square root of x. Now, let's talk about how to evaluate this using cube roots. If you want to find the cube root of y to the 11th, same kind of idea. Take the 3 on the outside, divide into the inside exponent, which is 11. Now, 3 goes into 11, 3 times, remainder 2. The 3 means this is the exponent of y that goes on the outside, and the remainder 2 is the exponent of y that stays on the inside. So what this tells you here is the cube root of 11 is y to the 3rd, cube root of y to the 2nd, the exponent that's remaining. Simplifying radicals with variables is actually a lot simpler than numbers if you know how this works. So I'm Jimmy Chang, and this is a very, very, very brief glimpse on how to evaluate radicals and expressions.